content from Russ Nicolai today about some of the idiosyncrasies, I'll call it, in the WSDOT sub-assemblies. I've got a little methods development update for you, and then we'll get right into the content. So if you could swing me over to my slide. Excellent. Okay, just a couple of reminders. With July 1st, we've got the Civil 3D mandate going into effect. So just a reminder that projects with solicitation and or starting with Lifecycle 11 after July 1st will not the local program. We've added, well, in February we added quite a bit of content to the FDM, mostly focused at project delivery. So that was dealing with our folder structure had already been there, but we got into a lot more depth on file naming, object naming, information there. And coming out, I'm not privy to the exact release dates for the FDM transmittals, but either yet this June or maybe early July, with the next FDM transmittal is going to be a lot of content focused on design models. So talking about predominantly initially surface models out of design and the specs for what they need to meet with regards to delivery to construction contractors. So that's going to be talking about what surfaces need to be built, when do they need to be built, what kind of density of points and feature lines needs to be in those, what kind of features need to be developed or are optional to be developed, and also talking about some of the requirements for delivering those files to the contractors in a format that they can consume in their software. All that information is going to be coming out in the next FDM transmittal. If you miss that or what have you, the vast majority of that content is going to be in 15.5, mostly 15.5.3 and its attachments, and 19.10.43 and its attachments. And that's that. So we just also pushed out, we believe, our last update to the 2012 standards. You should have got an email from me on that yesterday. The 2014 standards are going to be keep getting updated. Hopefully we can keep on the monthly schedule that we've been on. And that's all I got. So I'm going to turn it over to Russ on the audio.
Okay, this is Russ Nicolai. I'm coming to you from the Madison Southwest Region office. I'm Russ Nicolai. I'm the Civil Applications Engineer for Master Graphics. I've done quite a bit of work with WSDOT over the years, including some on-site works, support work, methods and workflow processing and so forth. The topic today is WSDOT sub-assemblies, and I'm hoping that some of my experience and some of my user interaction over the years is going to come through in this. In fact, a lot of what I've planned on talking about is based on discussions that we've had with individual users. One of the things I want to say right up front, and this is actually part of the presentation, is that the WSDOT sub-assemblies are not the only sub-assemblies that you can use. They are a gap filler. WSDOT, what they did was they took a look at what Autodesk provided out of the box and saw that there were certain things that Autodesk ones did differently than what WSDOT would like to do, or maybe there were some design features that weren't able to be easily accomplished. So they went and had these WSDOT sub-assemblies created. So when we look at WSDOT sub-assemblies, we're looking at just a subset of what you can use in your everyday work. So with that, let's take a look at the agenda for what I'm going to discuss here. First of all, I'm going to start off talking about the WSDOT subassembly help files. Now, if you have accessed the Autodesk help files for those subassemblies, you'll feel very much at home. The format, the structure is very similar. And I think just data rich, lots of stuff going on in both of the help files for that matter. I think, and this just might be my own consideration, but I think people think that help files are for new users, and that's just not the case. I think every user of every stripe should pay attention to the help files, in particular with the WISDOT ones. It's got some real information in there that we need on a daily basis. So if you're missing the help files, you're really missing a whole resource that you really need to make use of. Then we're going to move over and talk about the subassemblies that need some explanation. Now, I kind of count this as kind of the highlights. These are the top ones that get asked about all the time, or people have issues with. We see some support issues with one way or the other. A lot of times it's just, oh, I didn't know that choice was there, or some function is, I turn on one part and that counteracts another one. So things that you just need to know going back and forth and how to use it and what to expect. The 5 that I'm going to focus on are the GenCF, or the cut fill, general cut fill, lane generic, lane pulverized relay both, and by extension we'll be talking about the left or right side as well. Urban median, and then the CG general, the curb and gutter general. Like I said, it's kind of highlights. I'm sure there are a lot more that we could talk about, but in a venue and time frame like this, those are the ones that we see most often needing some kind of discussion. And finally, then we're going to dip into subassemblies that need constant adjustment, or consistent adjustment, I should say. These are ones that the defaults are set in such a way that on a regular basis you may need to change them one way or the other. There's only a couple of them that I'm going to touch on. A lot of them are already discussed in the first section, but they're things that consistently you will want to, when I use this subassembly, I know I need to check these settings and probably need to change them depending on what's going on. So with that being said, let's, I'll thank you later, actually. I'm going to jump into my file here. Now I've got 3 different files. The power users, I believe, have them at their stations at the different offices. But that way I could kind of focus on a couple of tools here, switch over to a file, and so forth. The first one that we're going to talk about here is the GenCF. Actually, I'm sorry, before I go to the actual subassembly, I'm going to talk about the help file. The help file access point, the most direct one, is to just go to the tool palette, which in the 2014 install is off to the side here. And I'm going to go to the WISDOT tools here and simply right-click on a tool. This is the same as the Autodesk one, so if you're in the Autodesk tools, same rule applies there. Just right-click on a subassembly and at the bottom choose Help. That is a specialized written help file. In fact, this one is specialized to WISDOT. There's no Autodesk ones involved in this particular file. That takes you to the file that you, of the subassembly that you right-clicked on. And like I said, the format and the structure is very similar across the board. We'll have a little bit of a picture up at top that kind of spells out what some of the terms are, some of the important factors in the subassembly that you're looking at, but in no way a full comprehensive listing. Below that will be a chart of input parameters. These are things that you will be prompted for at the very beginning. Now, they all have defaults of one set or another, so you don't need to change them necessarily, but this area in particular will spell out what those parameters are and what maybe gives you a little explanation of what to expect out of it. A lot of times you'll get a setting that, sub-base stuff. What is that actually meaning? And it's going to kind of spell it out in the description area. I've seen a lot of confusion cleared up just simply by reading that little portion of it. So you can kind of jot through here and find important parameter information. Then there'll be a section on target parameters. I think this is as important as anything in the help files, because the target parameters can really make a subassembly do a ton of other things besides what the strict parameters do. They're overrides at the beginning and end of it. In this case, this particular subassembly has a width and outside elevation, or think alignment or profile targeting. That way I could change the slope by targeting a profile, or change the width of the lane by targeting an alignment. Many times on a support call, I will be dropping in here and checking the targets in particular and say, well, can we carry out what they need to do on this by targeting something? And a lot of times it's a great override, gets you past a lot of issues. Below that, and not all of them will have this, but the output parameters are available. Now, what the output parameters on a subassembly are for is to pass information from this subassembly to the next one in line. In particular, this lane could pass on slope information and some other information, you can see it listed there, to a curb and gutter perhaps, or to maybe another lane. This is information that's available for moving back and forth, and you can see here there's quite a few fields that are available. Not all have these, but those that do, that can be a useful tool for making sure that numbers all work out across the length of your design. Below that will be an area on behavior. It basically spells out some nitty-gritty about the subassembly. And then one of the things that I think is terribly important here, and especially for the way that we're going to be building surfaces, and that's the coding diagram. The coding diagram, in particular the point codes in this diagram, are going to spell out what the codes are that you're going to need to create the feature lines that then create your surface. So one is needed to do the next, that needs to do the next. A little bit later, I'm going to add in a code, and you'll see that I'm very, very particular about how I type it in, and it's because I looked it up in the help file, and I know the spelling, the capitalization, where's the underscores, where's the spacing, that kind of thing is all critical to this. If you spell something wrong or get something wrong about the code, you are creating a new one rather than just using one that's already baked into the subassembly. Now, I'm a graphic kind of person, so down below is a little map that kind of spells out P1, where exactly is that on my subassembly? I find that absolutely necessary, absolutely invaluable to figuring out where things are located. So now that being said, I opened up that help file fairly easily. There are times where I've talked to users or actually seen it for myself where they will right-click on an object or on a subassembly, choose help, and nothing comes up, or actually a blank one comes up. It seems like the CG Gen is one that this happens to. In fact, it'll happen on mine. Sometimes other subassemblies, depending on how things were installed on the machine, perhaps, you may be missing something. I'm going to right-click on CG Gen and say Help, and you'll see because it doesn't understand what it's looking for, it goes to the Autodesk help file, and it doesn't understand what CG Gen is, so it's basically nothing. Not to worry, there's a way around this, very easily fixed. I'm going to close out that non-useful help file and right-click on any other subassembly in here. Now, if you right-click on one, and again, that happens again, just try right-clicking on lane generic. That'll get you into the help files at least. I'm going to right-click on urban median. It's the next one down below. I'll go to help. On the left-hand side of the window is a listing of all the subassemblies. The reason I picked urban median is CG Gen is right next to it. So, we're right next door. Very easy to left-click on CG Gen, and there's my data. So just because that right-click didn't get me there doesn't mean that I can't get there originally. Another way to get into the help file is to either pick the subassembly itself or to pick the assembly as a whole. Now I'll go into the assembly properties here. The subassembly dialog is the same in that down in the lower right-hand corner is the subassembly help button. In the assembly, I actually have to choose the subassembly that I want to go to. I'm going to pick lane generic. Actually, I'm going to pick the Gen CF and click the ellipsis button. The reason why I picked the Gen CF is notice that it took me to the lane generic automatically. A lot of times you'll see that happen, and again, on the left-hand side, you just browse through the list and find the subassembly that you actually wanted to look at. I'll just come down here to the barriers and curb, click on CG Gen, and I'm back to where I needed to be. So that's the help file. Like I said, if you're not accessing the help file, then you are flat out missing stuff. You're going to want to have that at your disposal, especially for the surface creation portion. What I've done in some cases, I've printed out pages that I use a lot. That way it's at my desk. I don't have to pop that open necessarily. If it's a subassembly that you don't use a lot, by all means, it's a great access point there. So now with that being said, let's move on to the subassemblies that need explanation. I'm going to start off talking about the Gen CF or the cut fill. The cut fill subassembly in the layout mode that we're in right now looks like a kind of sideways V. Whenever you see a subassembly like that, that means that it's doing some calculations for you, maybe cut, maybe fill, so it's kind of giving you a graphic indication of that. Now I'm going to left click on this and go into the properties. Now generally we would go into the subassembly properties directly, but I want to show you what it looks like when you create with this or when you use it to build an overall assembly. So I'm going to right click and choose properties, and you'll get the properties dialog box. If you were building an assembly, you would see this as your first point of data entry. I'm going to slide down to the bottom where the advanced parameters are located. And the first thing in here that I'm going to point at is the override ditch bottom elevation. I'm going to highlight it on the screen there, and you'll notice that by default that is set to no. What that means is that in certain circumstances, it will create this subassembly will create a ditch, but it is basically doing a ditch on basic numbers. It's a very stringent kind of rule process. In fact, if I let that close up, you can see that I'm on the left-hand side, and right now the subassembly does have a ditch involved before it goes up to daylight. If I come back over here to the override ditch bottom elevation, I'll click that drop down. I've got two other choices besides no. Elevation, which is a hard elevation. If I choose that option, the field right below that, right now defaults to 800 feet. We're up in the 1245, 1250 kind of range. So you may need to go in and actually change that to a legitimate elevation there. That is a hard elevation, so it's always looking for that elevation. If I click the ditch override ditch bottom elevation again and choose profile, this is going to allow me to identify a profile that's identifying the elevation of the bottom of the ditch. Now, in my file here, I happen to have an alignment already out there and a profile already built. I'm going to zoom in on my view edit section here, and you'll see the red line indicates where the alignment is located. The green circle at the bottom is actually indicating where the proposed profile for that ditch bottom is located. In this, what's going to happen is when I target that, this slope will continue on at 6 to 1. I believe there's actually a point where it gets to the rollover point, and we'll get to a 4 to 1 portion. But basically, it's going to end up, the ditch bottom will end up at the elevation of the profile. Not necessarily the alignment location, but the profile elevation using the slope to get there. Then at that point, it takes a left-hand turn and goes back up to daylight, as we would expect. Now, that being said, with profile turned on, I'm going to go over to my corridor. It's already knowing that it needs to be rebuilt, but I'm actually going to check something before I go there. I'm going to go into the properties of the corridor and then look at the targets. Scroll down to the bottom where the profile targets are, and you'll see ditch point elevation. I already have it assigned. I knew this was coming, and so I assigned it, got in, realized, oh, wait, it's not going there. Oh, I've got to turn on that switch to make it respond to the profile. So once this is set and the subassembly is told that it should be looking for a profile, I'll click OK to get out and rebuild the corridor. Dialogues are on top of each other here. A second. I'll rebuild the corridor, and now you can see in our section editor here, it goes down to 4 to 1, hits the clear zone, I should say, not the rollover, but the clear zone, and then drops down to where that profile is. If I advance along our sections here, you will see that green circle moving. The alignment is shifting left and right, but really the elevation of where that profile is where that ditch bottom is continuing. Another item that is in the properties of the Gen CF is the minimum fill height. Right now the default for that is set to 1. What that is allowing us to, in a technically fill situation, if it's not a lot of fill, we can allow it to go into a cut situation before going into a fill. Now I'm going to point out here that we are in a section here that's just a little bit in the cut. Eventually we will get into a fill area, but if I advance through our stations here, in fact I'm going to advance to station 325, and you'll see here the origin point of our the cut fill subassembly is here at the edge of the pavement. The measurement for this is 1 foot, and as long as that is less than 1 foot, even though we're technically in a fill situation, it's saying, okay, I'm going to override and allow this cut to continue on from here. A lot of times we'll see things where you think you're really close to the ground and you think you're in fill, but suddenly, why is it ditching here? That could be turned on, or by default it's already set to 1 foot. So it's something that you can watch for. If you measure that distance out, you'll see that it's less than 1 foot. Now if I advance ourselves along our design a little bit further, eventually we get to an area where we do actually get into fill. So that is a 1 foot minimum. You can set it to a less or more number depending on the situation that you're in and get a different result. Next thing I want to look at here is what's called the connecting link. I'm going to go to the right-hand side for this. I wanted to have different things on different sub-assemblies here. And I'm going to go over to a station that I know it'll be fairly obvious, is station 50. And here, what's going on, if we go into the sub-assembly properties again and go down and look to the connecting link slope and minimum width of connecting link. Right now it's set to 4 feet. Now I'll let you know that I have rigged these numbers up a little bit just to make sure that I'd have something to show here. I believe the default for that is 8 feet, so it's a minimum of 8 feet. What's really going on is in a cut situation at a ditch point, at a ditch elevation, the tool is starting off here. It's going to your clear zone here, and again, I adjusted the clear zone way in so that I could force this to happen in a way that I could show it. So we've got a line that's going down to our clear zone here. There's a purple circle here where that clear zone mark is. Then it comes down here to the ditch point and comes back up to our minimum width. Then everything in between there is our connecting link. Now I intentionally came in here and turned the connecting link to 5:1. The default is 4:1, but that would have been the same as one of my other links. I wanted to make sure that you could see that it was a different slope there. So we have 4:1 starting out, then 5:1 connecting link, and then 6:1 for the down to the ditch. It's basically a way so that we can kind of connect up where that data would be ending if we didn't have a tool provided there. And with that, I'm going to close that out and go over to talk about the lane, the generic lane. In fact, I've got one in here. In the generic lane, a couple things that we've seen come up from time to time. One is the slope of the lane itself, and not the lane itself so much, but the subbase of the slope. From time to time, we'll get a phone call from somebody who's changed the slope of the lane, but the subgrade hasn't changed to meet it or match it. And that's because the top and the bottom actually can be controlled separately or differently. Up towards the top here, we have a fixed slope for top pavement. That's controlling the top of our pavement up here. If I change that from a -2 to a +2, again, doing something radical so you can see it happen, you'll see that the top has changed, but the bottom has not. The bottom is actually under control of the subgrade superelevation method and the fixed subgrade slope working together. Now, the subgrade superelevation method right now is set to fixed slope. The default is not fixed slope. I did that again so we could see it happen. But the default is actually use outside lane superelevation. If you have a superelevation related to your alignment, the bottom of this or the subgrade of this will automatically follow that no matter what the top is doing. I changed it to fixed slope so that I could say -2% there. If I change that to +2%, you'll see that our assembly here is fixed immediately. If I rebuild the corridor, that whole lane would shift up 2% and we'd have what we expect. The other options that you have down there for subgrade superelevation would be to follow pavement. Basically, that is whatever the pavement's doing, I want you to do that as well. That happens in superelevation regions, though. If you have a number that you need to hit, make sure that you use the fixed slope option. Down below is use inside lane slope or use the opposite side outside lane or inside slope multiplied by -1. Basically what that means is if my opposite lane is -4%, I want this to be +4. It's doing 4 times -1 to flip that number over. So you get a reverse. So those are the functions to make sure that those slopes are reacting correctly. In fact, I believe before when I rebuilt it, the lane was actually responding to the 2% slopes there. So another function that we see a lot of, and sometimes this gets people into trouble, is the crown location function. Now, I'll mention this as an Autodesk subassembly also has the crown location function, and again, it will apply there as well as here. They use it slightly differently, but it's very, very similar. The crown location right now defaults to inside. The choices that you actually have are inside, outside, or none. You want to be careful what you choose here. If you are doing what I've got here, in fact, I'm going to change my slopes back to -2 so I have a regularly crowned road. If we are working from a crown going outward, that's where we're building our crown from, The inside point is good because that is actually where you're attaching it to the roadway design. If I chose outside, that actually means that I'm starting here, the crown point is actually here, and the lane is going backwards. That would put the crown point at this location, 4 lane starting at your edge and coming back. Now the last one is to put no code at all, and this can be a little bit dangerous, but as long as you understand what you're getting, you can make adjustments for this. If I choose none for this, that actually turns off the crown point altogether. Now this could be useful if you have a multi-lane situation. I've got one lane that's 2% with a crown here. The next lane over is at 3% or 4%, but it doesn't have a crown point. It's going lane to lane. You might want to suppress the crown points for those types of things. Now, I want to call out this specifically because that does affect what you have to build surfaces with. That actually turns off the point code, which turns off the feature line, which means you can't build a surface to that particular point code later on. So as long as you know that's coming, again, make allowances for that. I want you to watch what happens over here in our assembly when I turn that back on. Currently, I have both lanes set to none. I'm going to set the crown point to, I set the crown point, I'm going to slide down there we are, crown location to inside, and you'll see that text pops up here immediately. In fact, that's what's driving this label here in our actual corridor. So be warned of that, beware of that, especially if you have a surface that jumps across that, or if you're building a surface and don't see the crown option, that's your first usual suspect, is that someone's turned off the crown point. And finally, I want to talk about a little bit last about the pavement here is the measurements here. Autodesk subassemblies are measured as just different material depths. I need 4 inches of this, 4 inches of this, 6 inches of this, and so forth. This subassembly is actually measured from the top going down. And really, as long as you get to the same depth, that's fine, as long as you know what you're getting. And actually, I'm doing this particular topic so I can show you an error that crops up if you get into a certain situation. If I go in and tell this subassembly that its depth, right now I've got 6 inches of top and base depth is 1 foot. The sub-base depth is actually 1 foot, 1.6 feet down. My base is 1 foot. If I tell the 1 foot, that's 1.25, let's say. Now watch the subassembly off on the right-hand side. You'll see that that layer drops down to that elevation from the top. If I continue on, I'm not paying attention perhaps, or I hit a wrong button perhaps, I'll type 1.7, so it is just below the elevation depth of the sub-base depth. Then it can't handle that. It says, okay, wait a second, something's wrong here. Now, this is called the red slash because you get the little red slash here, a little red marker. The subassembly is still there, and I can tell you that because the daylight hasn't moved. If the subassembly goes away, that daylight will jump in and take up the slack. What's going on here is that red slash is indicating, wait a second, graphically, something is not right here. You're going to want to go back and refigure the numbers that you're working with. This will happen on many different kinds of subassemblies, so you will see it in other places. In fact, I think one that I'll change later, the curb and gutter, will actually have something like this as well. So with that going on, like, oh, wait a second, something's wrong. I'll pop back in here. The usual suspect is the depths. That's the first thing you should check. There are some other options here that may cause it. I'll click on base depth, turn back to 1.25, and okay, there's my subassembly. Oh, I meant to make that a 1.0. Set it back to 1 foot depth. So that is the lane generic and the things that you will see there. Let me switch over to the file that I have for the lane pulverized relay. This one is for taking pulverized material and relaying it into the design. Allows you to set some numbers so that you can set the different depths for how deep is the pulverized, how deep is the relay, how much is the overlay, and so forth. Also does some width adjustments as well. Now the one we're looking at does both sides together. You can do right and left at the same time. There is another version of this in the WIS.dot tool palette that does either right or left, so you don't have to do the whole roadway necessarily. The subassembly settings for this, notice when I click on it, the whole thing highlights. It's one piece. In the subassembly over here, I can go to the parameters. Let me zoom in on the left side just a little bit so we can see a little more detail. In here, I'll go in, and the lane width to the left, if I change that, it's right now it defaults to 12. I'll go to 14 feet. Now watch the right-hand window, and you'll see that that lane adjusts accordingly. If I scroll all the way to the bottom, there's a left side relay and right side relay width. They're defaulting to 15 feet. I'm going to set that to 13 feet, and you can see, again, what effect that has on the subassembly. Right below, actually, I'm going to go up a bit. Depth of overlay is right now 6 inches. If I say 8 inches, you can see the effect that that has on the subassembly. So you can kind of refigure the depths here and make some adjustments that way. At the very bottom is a pulverized relay factor. Right now that's set to 1.15. So basically that means for every inch that we are pulverizing, how much are we going to be able to move and how much are we going to be able to use in the section. Watch again the graphic here as I change that from 1.5 to, let's say, 1.25. And you'll see the adjustment. It actually shifts the material up some so that we can use more of it in our design. I'm going to set that to actually 1 so you can see it at a fairly deep amount. I'm going to set that back to 1.15 so it's back to its original setting. Now, that's a real quick overview of some real quick fields that you can adjust there. The part that I really wanted to show about this subassembly is the fact that it follows the existing ground surface and the pros and cons of this, and the pros and cons, where you might not want to use this because of that. If we look up in the section view editor here, again, the red line at the center is the alignment location. That's actually our baseline in this particular design. You'll see the green circle here. That is actually the proposed profile. I put in a proposed profile in here so that we could see where that's located. But notice the corridor itself is not following that. In fact, watch the green circle as I advance through the sections here, station by station. You'll see that that green line, or the profile, is actually moving upward, but the lane is not at all. This subassembly is not reacting to it at all. That's because it's built to react to the surface target. You have to give it a surface target for this to work. But that is controlling the elevation of where this subassembly is actually being used. And I don't know of any others besides the lane relay pulverized subassemblies that do this, but there might be another one out there somewhere. But generally, this is a fairly unique situation that it gets into. Now, this is where the warning comes in. The problem is that it is very dependent on the surface, so that if you don't have good field survey data, you will not want to use this particular subassembly. If you've just got DTM flight information, that's not good enough for this particular subassembly, so you'll have to go about it in some other manner, some other way to get this accomplished. If you've got field survey data and it is good, then this subassembly will fit into that usage. Let me switch over to another file here. I'm going to switch over to my urban median file. You can see here I got quite a bit going on. Really only one little part of this is the urban median, and that's the middle of this assembly. The urban median, generally you'll see 2 curbs and a median portion above it. I think it looks so much like an Autodesk curb and gutter that I always forget what it is. If you left click on it, the whole thing highlights. You can see actually better if I just hover over it. The whole thing highlights because it is one piece. Now, some of the things that you can control on this are the targeting of the median point. There's actually a median portion in here, and you can change the median point here. That's because you can also change the slope up to the median. If I zoom in my actual roadway design, it's showing that there is a slope involved in this that's not showing in the layout mode. Okay. Right now I think I've got 4% on both sides of it. It's going to a median point here. You'll notice that there's a red line, and our median is right at that red line. That's because I'm actually targeting the median to the alignment. So I can make that crown point of that median go wherever I need it to go, back and forth across our design. Now, with that selected, if I come into our tool here, excuse me, down towards the bottom is median slope constraint, which I have set to use median slope from right. And then the median slope from left and right are set to 4%. Now, by default, the median slope constraint is set to equal slopes. And that's fine if you've got a middle median. I got into some situations with this particular design where I'm moving that crown back and forth that it tried to make really tall, and for those of you watching online, I'm using my hands to indicate a very high mountain peak or a valley drop down. So it really kind of didn't do what we wanted it to do there. So Basically, I'm telling it that I wanted to use the median slope from right as the default, and then the left makes up the slack for that. That way you get a nice slope of this. If I advance down my stations here, I'll go forward. Actually, let me zoom in and lock that view in. Oh, there we are. And I'm going to just advance along here, and you'll see that that red line shifts outward, and the right-hand side is clearly longer than the left, but the crown is always matching up to that alignment. That's all the way through our design. Another portion of that is, and I always lose this one, the material under, here it is, a full depth of subgrade through median. If I click this bottom field here, right now it's set to false. With it set to false, you'll see that there is a extended subbase material underneath here, but it does not go all the way through. If I choose that and change it to true, you'll see that this shifts to include a subbase material all the way through the base. If I rebuild the corridor, I would get that all the way through our design as well. So that is what the full depth of subgrade material through median is indicating. Also, this particular subassembly operates with what's known as a marked point. You'll see up towards the top, in fact, it's the first field that actually we can adjust. It's the marked point name field. By default, it gives it a name of RT. Now, RT is fine as long as you put a marked point out there that has RT as its name. What I've done here in this particular design, the marked point tools generally are, in Autodesk's world, are meant to work with an offset assembly. And you would attach it to an assembly off to the side and actually come backwards with your design towards the original. You're using the marked point as a way to magnetically connect it up or to fill that gap. Well, the problem is, well, there's a series of problems. One of the more serious ones is the surface that WISDOT wants cannot be created when you're using an offset assembly. So we're going to have to jettison that thought process and go into using this subassembly from its original assembly. So everything is attached to this assembly here, and we're always moving to the left. But this curb and gutter still needs a marked point out there so that I can widen it. You saw how, as I advanced, the median got wider. Well, that's because I have a marked point employed. I just have a kind of a fancy way of doing it. What I've done, and it's very difficult to show here, so I'm going to kind of sketch out what I did and explain it. What I did was I went in, first turn off my updates. I first went in and created a generic link from this point over here to put an anchor point here. I put my marked point on that anchor point there. That has to happen before I place the median tool itself, or else it doesn't see it, doesn't react to it. I put that anchor point in, or that median point in, with the name of RT because I knew my median tool automatically defaulted to RT. You can name it whatever you want as long as they're in agreement. A lot of times I'll name it MD for median, or LT for left if you're going to the left-hand side. As long as they agree, it will work. Then I came back to this point here and placed the urban curb and gutter and dropped it in on that point there, telling it to go back to that marked point. Then the lanes and everything else that follows after that are attached to the median tool itself, and that way they can all move as one piece. That is not the only way to accomplish this. This is just one of the ways that I've seen work well, and it works kind of straightforward. So it's a way that you can use this particular median in your design. And finally, I'm going to use this subassembly, or this assembly, to look at the curb and gutter, the CG Gen subassembly. Like I said, it looks somewhat similar to what we had for the urban median, but we've got some other things in here. If I highlight on it, I've got the curb and gutter, I've got the subbase material extended, I've got a portion here that is the top material above the subbase extension, and then I've also got a terrace area here. Now, the terrace area measurement is actually happening from the back of the curb. This is something that's easily missed. You know, some people I've seen measure or assume the measurement is from here, and they get an erroneous measurement because it's not from there, it's from the back of curb. Let's go into the properties here so we can take a look at that. And you'll see here down at the bottom is terrace width. Right now it's set to 6 feet. That's the default out of the box. If I set that to 5 feet, watch our right-hand window there, and you'll see that the whole thing shifts over by that amount. Now I'm going to look up here to the subgrade width. That's actually indicating how far back that extension is going. It's 1 foot. If I come down to terrace width and set that to 1.25, I'm still fine. I'm a quarter of a foot farther than the extension. If I set this to 0.8, let's say, I get the red slash because I'm now inside the parameter of another part. And they're fighting each other, so therefore, graphically, they want to let you know things are not going to turn out well for you if you leave it in this kind of condition. I'm going to set the terrace width to 1.5, let's say, and again, it comes back. The part is still there. It just graphically is letting you know that, yeah, things are back in business. I'm going to set that to 5 feet, let's say. So that is the subassembly, the gen tool there. Now, the other thing about the CG Gen was the use of the output parameter. I want to call this out because it's one of the tools that makes good use of it, or I've seen time and time again make use of it. If I want this pan to be the same slope as this lane for whatever reason, I can go into the assembly. Now, I have to do this through the assembly because it's the kind of unifying factor between all these sub-assemblies. If I go into the assembly, I'll go into the assembly properties, construction tab, and then I'll go to the right-hand side, make sure I'm going to the right-hand side, Gen CF, and then on the right-hand side of the input values, you'll see that there's a use column for parameter reference. I'm going to scroll through here and find that I want to use my, Gen CF, I'm sorry, I should be going to the CG Gen. CG Gen, I'm going to scroll through that list and find my gutter slope. Right now my gutter slope is set at a negative 6.25. If I check mark use, that opens up the get value from field behind it. Get value field will say none, but it'll highlight. It won't be grayed out. It'll highlight. I'll left click in there, and these are all settings. Let me zoom in on that so you can see that a little bit better. These are all settings that come from the lane that is attached to it. If you don't have a lane that is immediately attached to it, you will get nothing here. It'll be blank. Unless you're attached to some other object that has some settings that they might not be settings that you want or could use. So make sure that if you're using the output function that you are connected directly to the object that you're getting the data from. So I'm going to uncheck mark and say cancel. I'm not going to do that for our design here. Okay. Now that in turn leads us to talk about subassemblies that need slight consistent adjustments. These are things that if I use the urban curb and gutter, or I'm sorry, the CG Gen subassembly, generally I will always need to think of this one factor or go in and fix this in one field or such. The subassembly itself is fine, but you will notice that the, need to reach on my screen there so you can see it. Notice the surface, which is this purple line through here. In fact, I'll left click on it so it highlights a bit. That surface is coming down the bottom of our ground here. It's going from the crown subbase point over to the edge of travel way subbase point. Then it skips up to the back of the curb and gutter and continues on from there, completely skipping the subgrade point down here. The reason is that this point down here is directly beneath this point here. And surfaces do not like to go straight up and down and don't like to go backwards on themselves. So since it is perfectly vertical here, that causes it a problem. It can't see that particular line that's above it, or that point code. So what we're going to do there is kind of trick it into giving us the surface that we want. What I'm going to do is place in a generic link and then give that generic link a certain code so it will respond appropriately with the surfaces. Now there's a couple different ways to do this, a couple different schools of thought on this. One of the ways that you could do this is put the generic link here and going outward. Now the amount out is going to be very, very small. In fact, so small you can't see it. It should be 0.01. I'm an extremist. I'll go 0.001. So it's very, very small. No one could ever see that it's there, but that's enough for Civil 3D to make the difference. If you do it this way, you do need to come down. You first of all need to give this point here a unique code, P3, P4, something that's unique. And then also you have to tell this code here not to be optional, not to be turned on. I don't want to use that particular code to build my surface. What that's going to do is force it to start here, come to this point, and then, and again, I'm exaggerating this greatly for your, so you can see it. It will then go up to this point and continue on from there. If this distance is very small, you'll never see that kind of slope, and everything will look appropriate. Now, the one that I like and the one that I'm going to show here is I like to put the generic link down here and have it go inward. That way, again, this point code is to the inside of this point up above, and will allow the surface to get from one point to the next point and then up again. The reason why I like to do it at the bottom here is I simply take the name of this code here and put it into this point here. What that means is the corridor already is looking for this point. It already knows it exists, and it's already using it, probably if you're at this phase of your design. By using that point code over, it says, well, I see two of the same code, but I'm getting to this one first, and now I can get up to the top portion of this without an issue. So that's the way that I like to handle this myself. I'm going to come down to our assembly down here. I'm going to go to the tool palette, and in here you can use a generic link to do this. If I scroll down in the WIS.dot section, there's a section of generic links. They're usually blue in color. You'll hear me call them blue links from time to time. Link, offset, and slope is a decent one to use here. I'm a little bit careful of any subassembly that uses the word offset, because offsets are actually measured from the baseline. So if you use an offset, generally that means it's measuring from here over to the point that you want. I do better when I'm using the width tool. So instead of using the offset here, I'm actually going to switch over to the Autodesk subassemblies. The generic tab of those. Towards the bottom is a link, width, and slope option. And again, width means it's measuring from its start point to the distance that you want it to go. It's not measuring from some other point. I'll click on link, width, and slope. In our tool palette for that, it doesn't really matter what side I put on here because I'm attaching it to the right-hand side of our assembly. The assemblies are smart enough to understand what things were attached to the right-hand side, which things are attached to the left-hand side, and they automatically make those adjustments. Well, that's going to work against us in this case because I want it to go on the right-hand side but head to the left. So I'm going to change the width from 10 feet, the default 10 feet, to -0.1. Now, honestly, this number I would make much smaller than this. I want to make it so you can see it. Again, I'm exaggerating it. Not often where you can say 1/10 of a foot is an exaggeration, but that is the case here. I'm going to zoom in on our assembly here. I'm sorry, let me make sure that I have any other settings that I want. I'm going to go -0.1. The slope is 2%, and that does generally match that. Now, I intend to make this so small that the slope won't really matter anyway, but if you know the slope, by all means enter that right away. That does fit mine. The point code here, this is where I need to put the point code. The default point code is 0.2 or P2. You could add a code to this if you want to maintain the P2 for some other reason. I'm just going to erase P2 and replace it with my own. Now, you'll see that I'm looking on my script here because the code here is incredibly important. If I spell it wrong, if I use all lowercase instead of putting some capital and some lowercase, if I don't put the underscores in, I'm creating a new code rather than utilizing the one that's already there. This is where that help file is going to come in. I told you at the beginning that the help file is going to play an important role. This is where I would either pull it up and have it on another screen, print out the page perhaps and put it out. You may really get used to certain subassemblies. The CG Gen, I'm sure you'll get used to the codes that you need and you might have it committed to memory. But there are going to be some that you use a lot that just don't resonate. Print it out, keep it on your desk, and make sure that you have it accessible very quickly. So the code that I'm going to put in there is capital ETW underscore capital S lowercase ub underscore capital CG. Now down below that, there's a link codes option. We're not worried about the link codes here. There is also an option in here to omit the link. Since we're not using the link, instead of cluttering up my drawing, I'm going to turn that off. Honestly, this will be so small that I don't think it matters if you leave it on or not. I like to do it just to keep things clean. I'm going to turn the omit link to yes. It's one of those weird things where yes means I don't want it. So it's a backwards answer. I'm going to swing into my subassembly, left click on the point where I want it to attach, and you can see that it has created a point code 1/10 of a foot over. Now it's very, very close, but there's enough separation. Hopefully you can see that. Now, with it still offset too far, I'm using air quotes there for that, I'm going to go up and rebuild my corridor. Because I gave it the code that's already employed for this and that I've already identified my surface with, I'm going to go into my corridor and rebuild, and you'll see that the surface rebuilds itself. I'm going to zoom in here, and the surface is going to that point and shifting up. Again, exaggerated for visual here, but you can see that it's going up. And generally, if we zoomed out far enough, you know, we would say, hey, that looks good. Now, to make sure that this is actually good, and to show you how immediate this change can be, I'll select on that subassembly. If you are overlapping and you have a hard time with it, I turn on my selection override command from Autodesk. Click on this, and it'll give you two options for subassemblies. I'm going to pick the one that highlights the one that I want. Go into the subassembly properties and change the width to -0.001. Like I said, I'm an extremist. That's a very, very small distance. In fact, we won't see any difference whatsoever. And why I think that's important is notice that there are two labels, because that point is labeling twice. Since there's no separation, almost no separation whatsoever, you can't tell that there's two labels there at this point. If I come back in here and rebuild our corridor, the surface now is so close that you can't even tell that it's caused a problem. In fact, I'll highlight it so that I can prove that it is there. It didn't just go away, but our surface is now complete. So that is one of the consistent things that you're going to have to do, especially if you're using a CG Gen subassembly, and that's going to come up. Also, I did notice, I didn't necessarily work with this, but the median surface also does that. So again, you'd have to do that again for the median here. In here, going to want to check the point code down there, make sure that you get the right point code employed. Now I'm going to zoom over to the left-hand side here where we have a select sub-base shoulder. Zoom in on both of those there. And you'll see there, when I reach on my screen, that the surface does the same thing. It comes up from the daylight on this side, gets to this point, jumps down to this one here, and continues on. This link here is vertical, by default, and therefore it doesn't cruise over there. Now you might be thinking, holy cow, he's going to show us that same process again. No, this subassembly has some tools built into it that you can use. I want to show it because it is slightly different. I am going to zoom in on that portion of it. So again, so when we build our surface, you'll see the change take place. If I go into the properties of this subassembly, I have two things selected there. There we are. If your properties window is ever empty like that, it's either the graphics card not keeping up or I had two things selected, so that was really my problem. I'm going to scroll over there, scroll down, and towards the bottom, I'm looking for a field that has 0 to 1 as the slope, because that's kind of an odd thing to see. Normally it's 2 to 1, 3 to 1, whatever. But 0 to 1 is slope. Is the slope of subbase closure link. Set the 0 to 1 as the default because that is straight up and down. If I change that field to 0.001 to 1 and hit enter, now that slope again has changed as close to vertical as we can get it without actually being vertical. If I rebuild that corridor yet again, the surface then goes over the top of our design just like that. Again, that kind of cleared it so it gets to this point first, then can continue down below and continue along our subgrade surface there. So those are the functions for that. Finally, there's one more that I wanted to point out, and I'm actually returning to the lane general, the lane generic, I should say. I talked about the subassembly earlier, but I wanted to kind of talk about this separately because it is something that consistently will come up. The default for a lane generic or LN generic is to have the profile target, the outside lane elevation method field, which is towards the bottom, set to no. That's the default. So right now, this lane, I don't care if I go into the corridor and assign a profile for it to target so that it'll change the slope. It's not going to respond to it because the subassembly has been told not to do it. If I come in here and click the drop down, you'll see, just like we saw before, an elevation option, which again will go to a hard elevation. Watch this because the default elevation is 0. It does not care that 0 is not realistic for a 1,200-foot elevation project. It's going to go down to 0 or try to. So make sure that you set in the elevation. Or if you set it to profile, that then turns on the option to target the profile that we have going on there. Now, I don't have a profile to target it to. Basically, just suffice it to say that in a lot of cases, if you do have a assembly that's going to a profile, that is going to be the usual suspect you should watch for and will cause that. You see it a lot in intersections in particular, because if you don't have it set to profile, the intersection tool doesn't know the switch is in there, so it doesn't know to turn it on, and your lanes are even though the intersection thinks it's going to whatever percent it needs to go to, it's stuck at 2%, and you get weird connection points. The surfaces will do what's called washboarding. They kind of go up and down in a jagged pattern where you see one surface fixed and then the next, then back and forth and so forth. So it's kind of one of those things that you'll see in intersections in particular. This is the usual suspect that causes that. You change that to profile, rebuild your corridor, and that should adjust itself appropriately. With that, that's the end of the information that I had to share with you today. I want to just kind of reiterate something that I said early on in the process here in the presentation, and that is that the WIS.dot subassemblies are not the only ones that you can use. You can use the Autodesk ones. You saw me do that here. I used the generic link because it fit something that I want to do a little bit better. So keep that in mind. Their help file is in the same function as the WIS.dot one, so you should be comfortable getting around in both. And again, they're both extremely useful. I would also say, troubleshooting-wise, if you get into trouble, check the sub-assemblies for things like vertical surface links. Check for things that targets are turned off or settings are turned off, or maybe two settings are conflicting against each other, like the measurements that you saw me do earlier, especially if you get the red slash issue. Those are things that you want to watch. And like I said, the help file can help during that process in a huge way. So thank you very much. I also want to thank those that are joining us online. The Q&A session, or the question and answer session, we are going to go local, so each individual office is going to go local. We'll do that here in Madison as well. For those of you joining over the web and not at an actual presentation site, I'd like to recommend that you might consider that next time. The process of doing a question and answer online was kind of difficult, not technology-wise, but just communication-wise. It was a little bit difficult to get questions out there to everybody. So we think it's better to try and do that locally. So those joining online, consider joining at a presentation site and registering for the live events. We're going to have a little bit more, a deeper discussion here, hopefully, as we finish up. The presentation sites, obviously, you can get to one that's in your area. This time through, it's at Madison, all the WIS.dot offices in Madison, La Crosse, Waukesha, Green Bay, Wisconsin Rapids, Rhinelander, and Eau Claire. If you need help finding a location, that's part of the registration process. We can figure out something to get you to one that's nearby. So thank you very much. And at this point, we'll be dropping the presentation from the live portion, and you can go to your Q&A sessions. Thank you.